Hi, I put this video together to share my experience with repairing the clips required to hold an Automation Direct Productivity 2000 PLC, power supply, and expansion modules in a 7-slot rack. The clips were damaged in a UPS shipment. I was unable to obtain replacements for the STL model for the clips. Luckily, several of the clips weren't damaged, and I was able to get dimensions from them. The original clips were injection molded in China, and the plastic appeared to be brittle. Hence, their locking tabs broke off as shown. Without these clips, the modules can't be secured in the rack. Trying to deal with a UPS damage claim, return the parts for replacement, etc. wasn't practical, cost-effective, or timely. I decided to attempt printing them on my Prusa 3D printer. The most time-consuming first step was generating a 2D profile of the part, which I did using a digital caliper to take measurements, then capture them in LibreCAD. The finished 2D profile of the part is shown. The same style clips fit all the PLC modules. 1 clip per module is required. Each clip pivots on a spring pin and uses the natural flex of plastic around a radius to create a snap action. A small tab extending from the module creates the actuation point to open and close the clip. I imported a 2D DXF file containing the clip's profile into FreeCAD and extruded it 11 millimeters to create the solid model shown. You could use FreeCAD Sketcher to draw the part, but I found using LibreCAD easier for this part. You may have a profile that isn't closed, which won't extrude. There is a link in the description that explains how to correct this problem should you encounter it. You'll need to know your way around basic parametric 3D modeling to create the solid. The solid is then exported to Prusa Slicer and set up for printing. I used PETG filament for this part. The broken OEM clip is shown on the left and the 3D printed replacement clip is on the right. The printed part has slightly more plastic in it and I believe stronger. Note the spring pin hole was modeled smaller since I wasn't sure about the fit. With a little experimentation, I found drilling this hole out to 81 thousandths worked out fine. This is the process to make a replacement clip. Let's explore how to disassemble and reassemble an expansion module. This example will use a serial communications module, but other modules are the same procedure. Here's a Productivity 2000 expansion module. This one is a RS 485 232 serial module. It's a plastic case. There's 6 clips that are on the back of the case. The easiest way to relieve the clips is use a push pin on each clip. Total is 6. So there you can see that right there, how that works. There's a bezel here that surrounds the status display. And on this particular module, there's a little plastic label with adhesive. So we want to get that kind of loosened up a little bit right there. Got to be careful not to damage it, but it's got adhesive. So we want to loosen that up just enough on the one side. So with all 6 clips pushed out of the way around the back here, and get in here with a razor blade, and you can begin to open up the case like this very carefully. You can see it coming apart, and work it around here a little bit. And then of course what you can do is you can remove these push pins for the clips that are already loose. Okay, so just carefully work this open. Get that label out of the way. Okay, if you're careful. Okay, so that's how you get the case apart. And it's a good idea in this particular module to take out this bezel here. You can remove that, that clips in. Right there, you want to take that out. So that's it. So that gives you access to your clip here. You can see the spring pin in there. If this was broken, now you can take this out and you can put a replacement in. So that's how it comes apart. With the module case open, remove the broken clip. Put an 1/8" through hole in a scrap wooden block. Clamp it in a vise or place it on a drill press table. Chuck up an 81/1000 drill bit so the shank is exposed, and use that to press out the spring pin from the broken clip as shown. The same technique can be used to press in the spring pin into the replacement clip. The spring pin should be centered vertically. Okay, let's assume that we replaced the broken clip. We want to put this back together, so we'll leave this bezel out. So we'll go over these 6 clips now. You got to be careful to make sure that you get the case on the outside of these 6 clips. You can probably see that, and just go ahead, carefully snap that in. Make sure your spring pin is in the hole there. Okay, so you just press that together. That's how that works. And then the last thing is to get this bezel put back in, which is a little tricky. So we're going to just go ahead and get that sort of snapped in place here. There we go. There, that snaps in there. So that's the last thing, and then here's your label, adhesive label that identifies those RJ45 connectors. There's 3 RJ45 connectors, so you want to push that back together. So that's pretty much it. It's all snapped together, and then here's your clip. That's unlocked, that's locked, and then your 1, 2, 3, 4, 5, 6 snap locks. So that's it. That's how it goes back together. Shown is a close-up of the repaired module with a 3D printed clip installed. This part won't have the same finish as an injection molded part, but is every bit as functional. It's also a stronger part, less brittle, and won't break as easily. The power supply and CPU modules use the same clip, but it's mounted in a plastic frame which snaps into the module. Not knowing, I took the module apart only to find out you won't need to take it apart, but carefully pry out the plastic frame. The clip will come along with that. Using the drill press method, press out the spring pin, install the replacement clip, and press the spring pin back in. I used a small drill press vise to press the pin through the clip. The pin should be flush with the frame sides. Snap the repaired frame back into the module to complete the repair. You may slightly booger the plastic trying to pry out the frame. This is very difficult to avoid, and if kept to a minimum, it's cosmetic only. I hope this video has been helpful.